Hello students, welcome you to this session. In this video, I am going to teach you conditional probability. See, what is conditional probability? Suppose I am taking two events A and B. A and B are two events. Then probability of A given B. So B is a given condition. Okay, so we are finding probability of A only under a condition B. B is just a condition. We are finding probability of A only. P of A given B is equal to, remember the formula, P of A intersection B by probability of B. Suppose you want probability of B given A. Here A is the condition. Under the condition A, we are finding probability of B. So here the formula, P of A intersection B by P of A. So you can remember very easily whether it is probability of A given B or B given A. Numerator remains same. It is P of A intersection B. Denominator is probability of denominator. You remember like this, so you won't make mistake, right? Numerator is A intersection B in both the cases. Denominator is probability of denominator. The first case B, so P of B. Second case denominator is A, it is P of A. Okay, so you can remember like that. Now, if I cross multiply, see if I cross multiply here, you will get P of A intersection B. P of A intersection B is equal to P of A into this, right? So P of A into P of B given A. If I cross multiply this one, the first one, P of A intersection B is equal to, you are getting P of B into P of A given B. So, for P of A intersection B, there are two formulas. You start with P of A or start with P of B. If you start with P of A, second time A goes to the denominator. If you start with P of B, then second time B goes to the denominator. Something you remember, okay? So then it will be easy for you to do the sums. And here another very important thing we are going to study, independent events. Already you know mutually exclusive. Mutually exclusive means nothing is common, right? A intersection B is empty set. Probability of A intersection B is equal to 0, right? P of A union B is P of A plus P of B. All those results we studied for mutually exclusive. But here independent. Two events are independent means, listen, P of A given B you are finding. You find P of A. What is the difference? In both the cases you are finding P of A only, right? So here you are finding P of A, there is no condition, but here there is a condition. Under that condition you are finding P of A, right? Suppose both the answers are same, then this condition is ineffective. When the condition is there, you are getting some answer. When the condition is not there, there also if you get the same answer, then this condition is not at all affecting A, right? So B is not affecting A. So that means A is not depending on B. A is not depending on B. Then we say A and B are independent. Okay. So the condition for independent is P of A given B is equal to P of A, or P of B given A is same as P of B, or you can say the most important thing, P of A intersection B. When you find P of A intersection B, you have to get P of A into P of B. How you are getting this, you know? When the two events are independent, please listen, when the two events are independent, you know P of B given A. P of B given A is same as what? P of B. Already we have P of A. This become P of B. So P of A intersection B is equal to P of A into P of B. Or in the second one, P of A given B become P of A. So P of A into P of B. So two events are independent. P of A intersection B is equal to P of A into P of B. Two events are mutually exclusive. P of A intersection B is equal to 0. Okay, so it will be very clear on that one. That's all the theory part. With this idea, we can do few sums. Okay, we start with question number 2. If A and B are two events, if A and B are two events such that P of A union B is equal to 0.7, P of A intersection B is equal to 0.2, P of B is equal to 0.5. Question is show that A and B are independent. What's the condition for independent? P of A intersection B is equal to P of A into P of B. So we want P of A also. So we start with addition theorem. We have P of A union B is equal to P of A plus P of B minus P of A intersection B. Substitute the known values. P of A union B 0.7. P of A we don't know. Plus P of B 0.5 minus P of A intersection B 0.2. So 0.7 is equal to P of A plus 0.3. Bring it to the left side. 0.7 minus 0.3 is equal to P of A. So you are getting P of A is equal to 0.4. Now you find both P of A intersection B. Already you know P of A intersection B is 0.2. Take it as 1. Also you find P of A into P of B. P of A into P of B. P of A 0.4 and P of B given in the question, it is 0.5. So 5 fours are 20, shift 2 digits, you are getting 0.2. Take it as 2. From both these values, so from 1 and 2, right sides are equal, so the left sides are equal. You can say P of A intersection B is equal to P of A into P of B. So the conclusion, therefore, A and B are independent. This is what they asked to prove, right? Prove that the two events are independent. Okay, now let's move on to question number 3. A and B are two independent events. It is given in the question A and B are two independent. So you know P of A intersection B is equal to P of A into P of B. This we know because it is given A and B are two independent events. And what else given? P of A union B given as 0.6. P of A equal to 0.2. The question is you find P of B. For any question of this type, we start with addition theorem, right? So we have P of A union B is equal to P of A plus P of B minus P of A intersection B. So P of A union B, no, 0.6. P of A 0.2. P of B we don't know, that's what we want to find. Minus P of A intersection B. Since the events are independent, P of A intersection B can be written as P of A into P of B. Bring this 0.2 to the left side. 0.6 minus 0.2 equal to P of B minus P of A, that is 0.2 into P of B. So this is 0.4 is equal to, take P of B common, you will get 1 minus 0.2. That is 0.4 is equal to P of B into, this becomes 0.8. Bring it to the left side. So 0.4 by 0.8 equal to P of B. Or you can say P of B equal to, shift one digit to the right. Both numerator and denominator you multiply by 10. You will get 4 by 8, right? So cancel 1 by 2. Or you can say 0.5. Now let's move on to question number 4. Listen, P of A given 0.5, P of B 0.8, P of B given A also given, they given us 0.8. See what they asked? They asked find P of A given B. They asked find P of A given B. What's the formula for P of A given B? P of A intersection B by P of B. You know P of B, right? Denominator P of B we know, but we don't know P of A intersection B. And the second part they asked P of A union B. That is P of A plus P of B minus P of A intersection B. So we want P of A intersection B, then only can do that, right? So since P of B given A is 0.8, that's given. So here you apply the formula, conditional probability, P of B given A. What is that? P of A intersection B by probability of denominator, it is 0.8. So P of A intersection B by P of A 0.5 equal to 0.8. Just to cross multiply. So you will get P of A intersection B is equal to 0.8 into 0.5. 8 5s are 40. 2 digit you shift, you are getting 0.4. Now substitute here the first subdivision P of A given B. P of A intersection B, you got it as 0.4 by P of B given in the question 0.8. So you can simplify this, shift one digit 4 by 8. So 1 by 2, it is same as 0.5. Second subdivision, they asked to find P of A union B, right? Second part is P of A union B. Addition theorem on probability, P of A plus P of B minus P of A intersection B. So that is P of A 0.5, 0.8, 0.5 plus P of B 0.8 minus P of A intersection B 0.4. So 0.5 plus 0.8 minus 0.4 is 0.4, right? You simplify, you are getting 0.9. Now let's move on to question number 5. If for two events A and B, P of A given us 3 by 4, P of B 2 by 5, and A union B is the sample space. So both the sides you take probability P of A union B equal to P of S. P of S is 1. So P of A union B is 1, right? So first you use addition theorem so you can find the unknown. What is missing here? P of A intersection B, right? So you can start like this. We have P of A union B is equal to P of A plus P of B minus P of A intersection B. Substitute the known values. P of A union B is 1. P of A 3 by 4 plus P of B 2 by 5 minus P of A intersection B. Bring this negative term to the left side, P of A intersection B. Take this 1 to the right side, it will become minus 1, right? Already we have 3 by 4 plus 2 by 5, then this minus 1. So first and second I am taking 20 as LCM. So 5 3s are 15 plus 4 2s are 8 minus 1. So 23 by 20 minus 1. Take 20 LCM. Or first result together you can take, right? 23 minus 20, so you are getting 3 by 20. So this is the value of P of A intersection B. But what they asked to find P of A given B. What is the formula for P of A given B? P of A intersection B by P of B. So we want P of A intersection B. That's the reason we got all these things, okay? So they asked to find P of A given B. So P of A given B, the formula, P of A intersection B divided by probability of denominator, that is B. P of A intersection B is 3 by 20 divided by P of B, it is 2 by 5. So you can write plus 3 by 20 into, write the reciprocal 5 by 2. 5 table you cancel, 4, right? So your final answer is 3 by 4 2s are 8. Now let's move on to the 6th question. A problem in mathematics is given to 3 students whose chances of winning are, I'm taking the 3 students as A, B and C are 3 students. The chances of winning, see, A winning A is solving the problem. A solving the problem is 1 by 3. So A not solving the problem, P of A bar, 1 minus P of A, that is 1 minus 1 by 3, that is 2 by 3. So P of A stands for probability that A is solving the problem. P of A bar means its complement, right? Probability that A not solving the problem. Same way, B solving the problem, it is 1 by 4. P of B is 1 by 4. So you can say P of B bar, meaning probability that B not solving the problem is 1 minus 1 by 4. Take 4 as LCM, 4 into 1, 4 minus 1, 3 by 4. And probability that C solving the problem is 1 by 5. So probability of C bar is equal to 1 minus 1 by 5. Take 5 as LCM, 5 minus 1, 4. Now see the subdivision 1 by 1. Well, first one is, what is the probability that the problem is solved? Probability that problem is solved. Listen here. 3 students are in a class. Your teacher is giving a question and going away. After some time coming and asking whether you solve the problem. Yes, as a single voice they are telling, yes, problem solved. Then what the teacher can guess? Who would have solved the problem? Sometimes the first person, A solved, other two not solved, but problem solved, right? A alone solved, or B only solved, or C only solved, or A and B solved, or B and C solved, or A and C solved, or all the three solved. In all the cases we say the problem is solved, right? It is not easy to find everything and add. So instead of that, we use the complement method. You know, P of A is equal to 1 minus P of A bar. So problem solved is equal to 1 minus its complement. What is opposite of this? Problem not solved. So problem solved can be taken as 1 minus problem not solved. Problem not solved means just a single case. A not solve the problem and B not solve the problem and C not solve the problem. And means intersection, multiplication, right? So probability that the problem solved is equal to 1 minus probability that the problem not solved. Problem not solved. That is 1 minus probability that A not solve the problem and B not solve the problem and C not solve the problem. That is 1 minus, everything is independent. So you can write it as P of A bar into P of B bar into P of C bar. That is 1 minus P of A bar. That's the reason we are finding everything. Okay, 2 by 3 into 3 by 4 into P of C bar is 4 by 5. Now we can cancel this 4 and 4, 3 and 3. You are getting 1 minus 2 by 5, right? So your answer is 5 LCM. 5 into 1, 5 minus 2, it is what? 3. So your answer is 3 by 5. So that's the answer for the first part. One more subdivision. What is the probability that exactly one of them will solve it? Exactly one of them. Please listen carefully. Probability that exactly one of them solved. Here actually there are 3 cases, right? Exactly one of them solved means A only solved, meaning A solved, other 2 not solved, B and C not solved. Or B solved, other 2, A and C not solved. Or C solved, A and B not solved. These are the 3 cases, okay? So probability that, so easy method you do like this. P of A intersection B intersection C plus P of A intersection B intersection C plus one more time you write P of A intersection B intersection C. Exactly one of them solved, right? So A solved, other 2 not solved. Here B solved, but A and C not solved. The last case C solved, other 2 A and B not solved. Okay, easily you can write it. Now since they are independent, you can write it as P of A into P of B bar into P of C bar for the first one. Second one, P of A bar into P of B into P of C bar. And the last one, P of A bar into P of B bar into P of C. All the values you know, just you have to substitute. P of A 1 by 3, B bar 3 by 4, C bar 4 by 5. So you are getting 1 by 3 into 3 by 4 into 4 by 5. Like that you can substitute all the values. Just I am writing here. P of A bar is 2 by 3 into 1 by 4 into 4 by 5. And the last one, P of A bar 2 by 3, P of B bar 3 by 4 into P of C 1 by 5. I'm not going to cancel. In some cases, see here 3 can be cancelled, 4 also cancelled. But for calculation, LCM purpose it will be easy. So 3 4s are 12. Denominator just you multiply. 5 4s are 20 and 360, right? Plus here 2 4s are 8 by 60. Plus last one 2 3s are 6 by 60. So LCM just you take 60. Numerator add it 12 plus 8, 20 plus 6, 26. Now we can cancel 2 table, 13 by 30, right? So the calculation will be easy for you. Now let us see question number 7. The probability that a car being filled with petrol will also need an oil change. So oil change is 0.30. The probability that it need a new oil filter. So two things we have. Let A stands for oil change and B stands for oil filter. So first one's probability P of A, oil change, it is 0.3. 0.30, it is 0.3 only. And P of B, filter change, it is 0.40. 0.40. And the probability that both the oil and filter need changing, both means A and B, oil and filter also, both and, A intersection B is 0.15. P of A intersection B is 0.15. This is what given. Now let us see one by one. First subdivision is, if the oil had to be changed, it is a condition. If it is a condition, right? So just try to understand. If the oil had to be changed, oil change means it is what? A, that's a condition, probability that oil change. Okay, if the oil had to be changed, what is the probability? This is the probability you are finding, right? So that you write in the numerator. Which probability you have to find? The first one is the condition. If the oil had to be changed, that is the condition. What is the probability that new filter is needed? New filter means it is what? B. Probability of B given A you have to find. What's the formula? P of A intersection B by P of A. P of A intersection B is 0.15, right? 0.15. So 0.15 by P of A. P of A is 0.30. Shift 2 digits. So 15 by 30. You cancel 1 by 2 or 0.5. Now let's see the second subdivision. Again, if, so conditional probability. If a new filter is needed, new filter means B. So that is the given condition. B is given. New filter is needed. What is the probability? What we are finding, that the oil has to be changed. That is A. You have to find P of A under the condition B, given B. So P of A given B, the formula P of A intersection B by probability of denominator, that is P of B. P of A intersection B, what is P of A intersection B? 0.15 by P of B. P of B is 0.40. 0.40. So shift 2 digits, 15 by 40. So cancel by 5 table. You are getting 3 by 8. If you divide, you will get 0.375. Okay. So practice these questions. Some more questions I'll teach in the next video.